I started all of this relatively recently. What I wanted to do was sort of look at ways to explore, sort of how things work, ways of breaking things down, analysing things and making them simpler so people can understand. And part of the reason that I did that is because of a bit of a pet peeve of mine, which is this media oversimplification, which seems to happen all of the time. And it seems to get into this clickbait stuff, you get it in TikTok, all those types of things, it's becoming a real problem. And so I thought I would do something about this whole thing, which keeps on popping up, and it's become quite frustrating for me. This NRMA Generator thing. The idea that having a solar recharge station with a generator backup and all that sort of stuff is bad. Anyway, what I thought I'd do is actually look at it in terms of breaking it down, understanding what's actually being talked about here and why, whether it matters, why it matters, what is it. Because a lot of it's been quite frustrating and there's a lot of polarization on it. I honestly, I'd love to see that go away. Part of that is because I don't think there's an argument in a lot of what's been talked about. It's a nothing. And part of the reason that I say that is because I think that people get over-focused on details which aren't there. It's like the car brand versus which one you'd actually prefer to drive. And so I guess where to start all this off is really, let's talk about what you're actually doing when you're putting fuel in a car. If you're picking electric or diesel or anything, right? What you're trying to do is go somewhere, right? So ultimately what power is, what electricity is, what diesel is, what petrol is, what hydrogen is, all of that is just a replaceable energy storage you stick in your car, right? And the important thing is, what you want to do and why you actually need it, not what the chemical makeup of that particular thing is. I don't see why anybody actually really, frankly, gives a shit past, the basic details. So ultimately what we're talking about here is really just a method of storing energy, nothing else. If you put diesel in your car, great. You put petrol in your car, great. You put electricity in your car, also great, right? But part of the reason I get frustrated about this is because of what sort of simplifying it down to the nothing of what that liquid energy, whatever is, sort of takes you away from and robs you of actually looking at and benefiting from. So I guess just to really drive that home, what I want to do is just show you through some real simple concepts here, right? And that is, if you look at battery energy that's going into a car, right? People present, you have solar panel, goes into battery, goes in a car, no carbon, whatever, right? That's one aspect of what we're talking about, but let's just look at it like a little chain, okay? So we talk solar panel, battery, car, right? That's great. Okay, now let's look at all these alternative fuels that are coming out, all that sort of stuff, right? So you look at, bioethanol corn, E85, that sort of stuff. And you look at algal diesel, right? Because that's another one that's proposed. So you can actually just grow algae on warm ponds, lots of surface area, grow it up, skim it, turn it into diesel, right? That's solar power too, right? But you're using diesel, which is great, honestly, because it means that people can keep using their diesel cars, right? But these are discussions we're not having because everybody gets focused on this other crap, right? Now, the third one, obviously, is, plants and dinosaurs go into the ground, get fossilized, pulled back up as oil, all that sort of stuff. Everybody learns about it in school. I don't think it really matters when you look at it, right? You can look at it as a big loop though, right? Because when you burn it, carbon and hydrogen go back into the air, right? They get pulled back into something else, and you can look at it as a big cycle. One of them is millions of years long, another one might be a year long, right? So that's a great way of staying on diesel while saving your emissions, whatever, right? But again, that's the detail I think it'd be great to get into, but we're not, right? So to sort of further detail it, what I've really done here is I've sort of detailed out, and you'll have to excuse me, I'm using a tablet for notes. So, but what does fuel do, right? Fuel basically turns into motion, right? There's a bunch of ways that goes through the process, but ultimately what you've got is a fuel tank, which is your energy storage, goes into an engine, burns it, turns it into a usable form of energy, goes in the transmission. The transmission only really exists to make sure that the engine's operating at the right speed and to get the power to where it needs to go. goes through differentials, which distributes it out through your vehicle, right? And then goes to your wheels and tires, right? Once your car's moving, all of that energy, the reason you have to put it in the first place, and we don't have Flintstone cars or something like that, is because you've got somewhere between, say, 5 and 20 kilowatts of rolling resistance when you're driving at highway speeds. Every time you turn, your tires change shape, they turn some of that into heat, right? When you brake in an internal combustion car, right, it turns that into heat too, right? When you look at a battery car, you have battery storage, goes to the electric motors, which do the distribution as well, goes to the wheels and tires, right? So that's a little more efficient on its own. But then on top of that, you can also use regenerative braking. So you take some of that energy back that you would otherwise turn into heat with your brakes, stick it back into your car, right, and charge your battery. Right, had a bit of an embarrassing interjection there. I forgot to charge one of my cameras. So we're going to go with the single point of view, I guess. Now, anyway, the point that I'm really getting at here is that this all really comes back to you get a neat benefit out of having an electric, like a battery in the drivetrain. That's how hybrids sort of win, all that sort of stuff. Right, so ultimately when we look at it, right, electricity is really just another transmission mechanism. And when you look at a generator, which is sitting on the side of the road or something like that, actually, it's sort of the same as having it in the car. So what you need to do is look at the efficiency of the transmission system. What's the difference? Really none. You can get the energy from more places with electric, and you can be a bit more flexible about it, but the main benefit's actually efficiency. There are massive efficiency benefits to running electric, and I'll show you the maths for that, because everybody seems to be pushing partisan bullshit. So what I'll do is I'll show you maths and sources, and that's the easy way. Electricity's also got a really low maintenance requirement. Piston engines take huge amounts of effort to actually get going and get working. It's nice that doesn't happen. So, if you've got to run around town, or if an electric vehicle actually suits what you want to try and do, great. If it doesn't, also great, right? Awesome. The other thing that hybrids, all that sort of stuff do, is they actually average your power requirements. One of the really big problems that you get with petrol engines and diesel engines, all that sort of stuff that are directly coupled to a car, is that you have all these peak requirements, and because you've got no storage on the vehicle, you end up having to size an engine to meet a peak demand, not the average. So while I was talking before about rolling resistance and aerodynamic drag, you normally see about a 20 kilowatt total cost for that. So it's not horrible. But I've driven cars and trucks with very little power, and that's not fun. So you need a bigger engine, and what that means is you have to pay the energy cost to have the bigger engine all the time, which is one of the places that all this stuff goes. Your transmission has to be big and heavy enough to deal with your peak demand. That's true for all of them, but yeah, it's a swings and roundabouts problem. It's not so straightforward as you think, right? Charging electric vehicles is a pain in the ass. If you can charge it at home, actually, it's a lot easier than petrol. But if you don't have a place you can plug it in, when you're driving around your house, when you're parking at your house or parking at your work, then actually it's a massive burden. I wouldn't do it. So let's jump into this NRMA thing, right? Now, I had a bit of a look into it. Now, the thing that they were showing with the running motor and all that sort of stuff, right? It's actually a really cool system, and they're originally designed for running hospitals and houses off grid. So if you have power outages, stuff like that. So what they do is you've got a little charge controller that actually preferences you one way or another. So it'll say, this is the source we're going to use first, this is the second source, this is the third source. Yeah, it's really neat. So what you do, and they manage batteries. So the NRMA one has I did it back of the envelope, probably 25 kilowatts worth of solar panels. It, according to an article I found, it's got 100 kilowatts worth of battery, or 100 kilowatt hours worth of battery storage. And it's got a 60 kVA genset, which will give you about 53 kilowatts to charge. And then they run through a couple of tritium solar chargers. Now, that's all super neat to know, but I guess the important part is what it really means. One is, most days you'll probably be running primarily off the battery unless there are like four cars charging, and based on the fact that that thing was empty and there was not even a person nearby it in the videos that I saw, I'm guessing that's not going to be a real risk. 100 kilowatt hours is enough to fully charge most Teslas and mostly charge even the largest batteries that you're ever likely to see. And when that happens, that means that you're running off. Solar, so there's no diesel usage at all. But let's go crazy. Let's just assume that, you know, clouds are in the sky. There's no visible sun. We live in northern Norway in winter, whatever. And so there's no solar, and we're talking about solely diesel, right? Now, diesel generators are super efficient. It's really cool. And that's because they get to run at one speed. And they get to be, you know, engines get really efficient when they get loaded up, and I'll show you a bit more of that later. But what I've done is I've just grabbed a representative 60 kVA generator because I couldn't find the specific one that the NRMA use. What I've also done is I found out they use a Tritium RTM50 charger, which has a listed full service 95% efficiency, so that's on their data sheet. I've got links on the page, you'll see all of that. So what we'll do is we'll just treat it as a bit of a case study, right? Now, a Tesla Model 3 is pretty efficient, so I've used that as sort of a good guide for efficient. And I've also used a Rivian R1T Max with all-terrain options because that was the worst possible electric vehicle I could find, right? Now, that's the same size as an F-150 with Raptor, you know, like Tremor or Raptor stuff. So it's big, it's heavy, it's bulky, it's messy. I'm going to try and see how the cameras are going. So I've got the cameras back now. Hopefully it's not too messy. So we'll look at this as a case study, right? So what we're going to do is we're going to look at a Rivian R1T Max with an all-terrain options. Massive battery, massive tyres, knobbly bits. F-150 Raptor style of competitor thing, right? So huge rolling resistance, really poor aerodynamics, all that sort of good stuff. And a Tesla Model 3, because that's actually one of the most common electric vehicles from what I can tell. We'll take the long range because it's got a big battery again. And what you get is you can actually work out how many watt hours you need to spend per kilometre. Right, now the Rivian at the extreme end is 262 watt hours per kilometre, right? So 1 kilowatt hour will get you not quite 4 kilometres. And the Tesla, on the other hand, is more like 8 and a bit. Now, if you go to a charging station, you look at the like a diesel only setup, what you'll get is, I've picked a Hyundai genset here, Hyundai DHY 65 KSE. To the best of my knowledge, that's an emissions compliant generator, catalytic converter, DPF, all that sort of good stuff. 60 kVA, does 48 kilowatts rated continuous output, which matches the charger. Yeah, battery's failed again. Right, let's go with that. There we go. Add more battery quirks. Right, so Hyundai DHY 65 KSE. 60 kVA generator, 48 kilowatt rated continuous output. When it's running at 100% load, it uses 14.2 litres per hour, which means you get 3.38 kilowatt hours per litre of fuel. And that's electrical power, not engine energy output or any of that sort of stuff, right? That's the juice out. I've included a link for that, so you can go look at the data sheet and explore that. Then you've got the charger, right? So it turns out, I think that the article that said that it was a Tritium RTM50 got it a bit wrong. It turns out that there's a Tritium RTM75, which comes in a 50 or 75 kilowatt charging system. And the 50 kilowatt one has a 50 kilowatt continuous rating, and it's rated for 95% continuous efficiency. So got them linked as well. You can go have a look at that data sheet. Now, when you boil all that down, and you have a look at a Rivian R1T Max with the off-road bits, right? You take your 149 kilowatts, or kilowatt hours, right? And then you divide it by 0.95 because that's your efficiency. And what you'll see there is that gives you 157 kilowatts of electrical energy into the charger to make the vehicle full from zero. Now, that's obviously an extreme example because you're never going to run it all the way to zero, but let's use it as an academic, right? And that'll get you 500 and something that'll get you 568 kilometers, right? So now that diesel generator running through that Tritium charger without any of that other stuff, no solar, no batteries, nothing, right? If you just hook one to the other and then to the car, you'll get 46.5 litres into the generator to fully charge the Rivian. Now, that might sound like a lot, But when you think about it, there are no big four-wheel drives with a 46.5 litre fuel tank, and that's because the Rivian gets 8.2 litres per 100 Ks when you treat it that way. And that's mixed usage, highway and city, right? So the EPA calculations for those cars actually involve a lot of stop-start. It's actually really hard on the cars. It's very hard to achieve good numbers. To give you a good feel, a Ford F-150 Raptor in the most efficient configuration gets 13 litres per 100 Ks on the freeway, and a Ford F-150 Raptor on the worst case configuration, which is 700 horsepower, supercharged V8, all that sort of good stuff. Cool car, love it. I've actually owned a Raptor myself. But that will get you 23 litres per 100 Ks. That is a lot of fuel, right? Now, that means to achieve the 560, whatever it is, you're going to be in for about, what's that, 125 litres of fuel, right? That's a lot of fuel. So that's really efficient. And the cool thing is electric vehicles, when you slow them down and you put them in those worst cases, they actually do better as well. Like the worst thing you can do with an electric vehicle, ironically, in terms of efficiency is to roll along at about 80. Or, sorry, roll along at about 100. Because you've got a lot of losses relatively to the sort of the other usages of power, so you can't recoup through regenerative braking, all that sort of stuff. You compare it to the Model 3. If you look at a Model 3, it's at about 79 kilowatt hours to fill. And then you're using 23.4 litres to get its 626, 629, something like that, kilometres. And so that works out to be about 3.7 litres per 100 Ks. Now, that's a car that actually achieves 3.700 Ks. That's actually a Toyota, what is it, Toyota, is it Echo Hybrid? Whatever the little one is, the hybrid. And that's real cool. But it's a lot smaller than a Model 3 and a lot lower spec. If you compare it to something like a Mazda 3, which is, you know, probably a slightly down market equivalent, but who cares? Mazda 3 gets between 5.5 and 6.6 litres per 100 K. So it's a little over half the fuel efficiency roughly. Or sorry, double the fuel efficiency. So it's really good. And this is all assuming there's no solar, you know, and a day without sun in Australia, even on cloud-covered days, you get solar power. You might get 20 or 30% the rated power of the thing, but you'll get quite a lot of juice still. So what's the point, right? The point is that actually, even without the solar and the batteries, which are there, it still is a really efficient way of powering a car. But let's skip all that and let's say, what are we actually looking to get, right? There are a whole bunch of ways of dealing with this, right? And the reason that I started this exercise by saying that electric isn't a competitor to diesel or petrol or any of those other things is because there are companies like Edison, right? What they're doing is effectively making a Tesla with a diesel generator on it, and they get shitloads better fuel economy. It actually works really nicely. But these are things we exclude when we start trying to beat down electric vehicles because, you know, it would be nice to have a vehicle that you could either, I mean, imagine being able to rent a genset, put it on your vehicle for a day, drive it around, right, when you need to do long trips, give it back to the people. You don't have to service the thing, then you just charge it at your home every now and again. You know, those types of things are innovations which go away when you say, I don't want electric, right? There's a whole bunch of cool stuff you can do that you know, when we jump into camps and we say, you know, like all the classics, no replacement for displacement. You know, electric doesn't make the right noises, therefore I'll never like it. All that sort of stuff, right? We lose that, right? Now, I guess it's worth actually going into why generators do better, right? Because this is one of the things that people harp on, you know, like, oh, well, it's the same thing, right? It's not. And the reason that generators do better and the reason that Edison and companies like that are actually doing something really cool is because you have what you call a brake-specific fuel consumption, BSFC, right? And what that is that tells you how much energy you need to put in to get the energy out in the format that you want, right? So when you're looking at something like a generator, what you do is you get this really like a map. It'll be a shaded zone map, or in the case that I've linked here, basically a big rainbow map. And so in this case, I've used it for, you know, I'm certainly not trying to claim the numbers off it. So what I've done is I've just picked something that looks about like what you get for any sort of brake-specific fuel consumption map. So I've just nominated a paper off ResearchGate, which isn't good practice. If you want to get into something, right, don't just pick a random paper, because you need to actually understand what you're referencing. If you don't understand it, you're liable to start telling people fibs. And I've seen that a lot. You know, I've seen one video where somebody who claims to be technical and knowledgeable picks up a paper, finds a table in it, goes, I like that number, points to that number, and then says, this is the answer that I like, and so I'm going to present that, right? And that's, you know, that's around this 85% charging efficiency thing, right? You'll get a charging efficiency map, but you can either use it through charge efficiency, all that sort of stuff, right? People do a lot of work on this sort of thing. Normally when systems are working hard, they work best. And when you look at the when you look at a genset, and you'll see that with this map that I've linked, right? In this map that I've linked, this is a petrol engine, and what they're talking about is optimizing for the Euro cycle, which is ironic given what we were just talking about. But in this case, look at this thing at about 3,000 RPM and full throttle, right? You're getting, in this case, let's take them at face value and say that the numbers that they're presenting are accurate. You're paying, what would that be? Probably under a litre of petrol to get 4 kilowatt hours of energy, right? Now, if this was a genset, you'd then have to send that through through an alternator rectification. That'll reduce it a bit. But this is why gensets do so well, because you do just park them in that zone and go, right? And then the computer turns it into power for you, and awesome, right? When you're driving a car, you spend a bunch of time at idle, zero throttle, low RPM, and you get zero BSFC when you do that, right? That's why a whole bunch of cars just turn the car off when you're idling at the lights. Saves you about a litre per 100 Ks, half a litre or a litre, depending on the engine, right? And then on top of that, they've got to optimize for a wide range. They've got to make sure that when you stomp on it, you get good peak power, all that sort of stuff. And so you've got to make an engine, like modern engines are really cool. People have done amazing work making these things just super broad, really efficient, all that sort of stuff. But when you park a literal ton of generator on a block and then design it only to produce power, you just do better. And especially because when you're charging batteries, you can make it work in exactly a repeatable way all the time. So you get good results, ones that aren't repeatable for vehicles unless you do something like Edison. So I guess, what's the point, right? What am I getting at? I guess where I'm going with this whole exercise is we're missing out on a whole bunch of really cool innovation because we're getting super focused on, I want dinosaurs to power my car forever, or some other shit like that, right? Our biodiesel is something that that is entirely doable. People have been working on this but can't get funding, right? I honestly think that there's some agendas there where people are trying to push against those types of technologies because they don't flip everybody over to batteries, right? But that's political. I don't think that matters. I think the sort of thing that actually gets everything going is somebody calls up BP or Shell and goes, hey, can I get biodiesel? That'll get you over that line. And those things, they're solar powered in the same way the stuff on your roof is, right? This is why it's important to understand the concepts. Now, am I saying EVs are the right solution for everything? No. Far from it. EVs are great for a certain use case. And they're super flexible, right? So, like if we went for the extreme end of the spectrum and people, we had somebody who was trying to do prepper stuff or something like that, you could potentially make an EV that runs off petrol, runs off diesel, runs off, solar, anything, right? And that benefit is the sort of thing you get from treating a battery as a transmission system, not as a fuel tank, right? I guess what I'm getting at is if everybody's not so hard down the line on these things, then what we get is we get a better outcome for everybody. So, think about it like this. If there's a diesel generator in the middle of the bush with a solar panel and a battery attached to it, and everybody shifts over to algal biodiesel. Let's take the gold standard magical future, right? What we've got is diesel as an energy storage, which is solar, and we're storing it as a longer term storage system than batteries in a diesel set, which is in the middle of the bush. And then you can store diesel and charge cars there. And that means that everybody can be running off biodiesel or whatever, right? But again, don't get too focused on the biodiesel thing either, because there'll be some new cool technology around the corner which will make it even better, right? When you look at four-wheel drives and that sort of stuff, electric in-wheel motors do amazing things, right? They are, they're the best case of a lock-in differential, a transfer case, air lockers, all that stuff, right? You can program to do anything. Really cool, right? But that's what we give away when we say, I want, 6.2 litre naturally aspirated V8 diesel, which produces 130 kilowatts. That's the Detroit diesel in the Humvees from the 1980s, right? And if you work them and you go real hard on them, you can get them up to 150 kilowatts before the block falls in half. Modern technology means you can get more kilowatts out of a 2 litre turbo diesel than you can that. That's great, right? But we're moving on again. So maybe in the future, we can rent a little 1 litre pot to get around when we want to go out for long drives. Or alternately, we can have, like a small diesel hybrid, or we can have, a lot less emissions restrictions on the remaining vehicles, because we've looked at the way that we're actually trying to power our system and we're trying to use the tool that's right for the job. People get all hung up on this, this guy's my guy, this thing is my thing, right? Part of the reason I'm sitting here is just because I figured everybody talking about this, right or wrong, seems to be sitting in front of a bunch of tools and vehicles and stuff, so I thought, fuck it, I'll do it too. This is my motorbike. I don't have few enough tools that I can hang them on hooks. I don't have that luxury of space. I'd need a wall half a K long. So I've got toolboxes here, toolboxes there, and toolboxes there, right? I've been doing this sort of thing for 20 years, probably more than that actually, as an engineer for 20 years, but I just get sick of this. Let's talk about the good things. Let's not get hung up on why the new thing is bad, right? The world's full of why the new thing is bad. Let's talk about the cool benefits we get out of it instead.